All the people with the backwards attitude, pointing fingers, and that's a bad excuse for sitting on your ass when you complain. Stupid things that you don't want to change. You ain't got no time for me, and I ain't got no sympathy for you.
Welcome to the empty horizon. Keep in mind that this is an empty horizon. There are no visible boats. As we zoom in, we see two boats appear along what I call the wavefront edge, which is the blue line of last discernible water. We also can see, as we zoom in further, something I call the mirror line. It is a reflection that forms under the boats after they pass the wavefront edge. Two major structural landmarks for this large ship are the top of the mast and also the top of the bridge, which could be considered the top of the body of the boat. It is clearly very large. The mast represents approximately 1/3 of the full height of the boat. Instruments and equipment attached to the mast structure create a visual line that divides the mast approximately in half. This interval therefore represents approximately 1/6 of the overall height over the water. As our target ship passes behind another boat, we can see that it is not going slowly. It is doing something that mariners call making land against the other boat in a noticeable fashion. We can also note that although the wavefront line is the same, it's consistent for our point of view, the mirror lines are different and unique to each object that is being reflected. The next time that this ship passes against other boats, we have a demonstration of the foreground, midground, and background effect. None of these boats is particularly close to one another in real space, but they look as if they are based on composition. May I also note again that this is not a slow-moving boat. It is traveling at significant speed over water. The background sailboat demonstrates for us an additional factor, the low-lying mist layer that sits over the water and acts as a distorting lens. Both effects are very well illustrated by this next motorboat, seen here entering on the left. The variations in density of the suspended water create visual distortions not unlike that of antique glass. The distortion is most observable in real time rather than when it is paused. The motorboat arriving from the right illustrates for us that it has its own mirror line that is distinct from the one of our main boat in the background. As the large ship continues to move away from us, more and more of it is falling inside the band of mist. Nonetheless, the observable structure proportions remain the same, with the mast representing 1/3 and the body of the boat 2/3 of the space above the mirror line. As the ship proceeds further into the distance, we find this continues to be true even as the distortion line rises to the point where it starts to affect the mast itself about here. The ship continues to move away from us, getting smaller in the distance. The amount of the ship that is inside the distortion continues to rise. As the distortion increases with distance, the white inflatable tender sitting on the deck becomes a white smear and melts into the sea, until only the davit that deploys it remains. The lensing effect essentially acts like a funhouse mirror, stretching the top of the image and compressing the bottom of the image over time. Here, as our ship passes behind a channel marker, we can make several observations. The channel marker has its own mirror line very, very close to our wave front. By contrast, the mirror line for the ship is much higher, seeing as it is much further away. Another indicator is how much smaller the ship has appeared to become. It is now more or less 1 story tall, maybe much less. Watching our ship make land against the channel marker reminds us that it is still traveling at speed and making significant distance over the time of this recording. At this point, both the top of the mast and the spreader bar level are above the height of the channel marker. As the ship moves away at speed, we recall that the interval between the top of the mast and the spreader bar can be used to calculate the expected height of the boat. That height is in no way inconsistent with the mirror line as we see. The distance between the top of the mast and the spreader is about 1/6 the height of the total boat. A small ferry or pleasure craft passes in front of us right along the wave front edge. And then another much larger ferry passes inside the band of distortion with its own nearer mirror line. As I take this moment to zoom out and observe the overall structure, keep in mind that now the ship appears to be shorter than the channel marker, and yet 1/3 of it appears to be mast, and 2/3 of it appears to be boat. Oh, and I'd almost forgotten. This started out as an empty horizon. Yeah, I mean, like, totally empty. There wasn't anything on it when we started, and that was 18 minutes ago. One last time, to be clear, the distance between the mast top and the spreader bar, and its distance from the mirror line is not inconsistent with the entire boat still being present above the mirror line, but hidden by distortion.
there. But doesn't it?